Apart from battery, let's quickly talk about another type of applications for electrochemistry and electrochemical engineering. These types of application or system or devices we call fuel cell. Fuel cell. Fuel cells are like battery. They are very l- similar to battery, except that the chemical energy is stored in a fuel, typically a gas or a liquid. When we think of gas, you can think of hydrogen gas, um, ammonia. Okay, when you think of liquid, it could be something like a methanol, or even you can think of gasoline or diesel. And the oxidant or the species to be reduced in a fuel cell is most often oxygen gas in the air, in the atmosphere. Okay, still, like a battery, it's converting the chemical energy stored in this case not solid but either a gas fuel or liquid fuel into electricity through electrochemical reaction. These types of electrochemical device or system are called fuel cell. Okay, and of course, a fuel cell system may contain many single fuel cells. And here we give an example of solid oxide fuel cell, solid oxide fuel cell, or SOFC in brief. This is a schematic for a solid oxide fuel cell. We have in the middle a so-called electrolyte, and it is a solid. It's actually an oxide ceramics called YSZ, or people call it yttrium oxide stabilized zirconium dioxide, or yttrium stabilized zirconia, or YSC. That is the center dense solid membrane. Okay, that is our electrolyte that conducts ion. What type of ion? Well, in this case, there are different ways to view it, but one way to view it would be oxygen vacancy. V for vacancy, O for oxygen, and oxygen vacancy, and it's charged. The dot represent this defect is, or this ion is positively charged. Okay, electrolyte, solid electrolyte in the middle, and then on one side we have a porous anode where the oxidation half cell reaction occurs. And if we are using hydrogen as the fuel, then the anodic or the oxidation half cell reaction for this fuel cell would be hydrogen gas combined with an oxygen occupy an lattice oxygen site to form a water molecule. Of course, in this case, we are talking about a gaseous water molecule. Create a, we said before, oxygen vacancy, V for vacancy, occupying oxygen site and with two positive charge, and also release two electron. That is so-called anodic or oxidation half cell. And of course, the fuel in this case is we are talking about hydrogen. In many cases, we are talking about hydrogen. On the other side of the electrolyte, we have the cathode, where the reduction reaction is happening. And the cathodic or the reduction half cell reaction would be for oxygen gas, O2 to combine with oxygen vacancy. The oxygen vacancy flow through the electrolyte and then combine with electron from where? Electron from what are released from the anode side going through the external circuit coming in. Okay, oxygen gas in the air, oxygen vacancy coming through the electrolyte, and the electron coming through the external circuit, and all these three combine to form oxygen occupy lattice oxygen, and it's neutrally charged. Okay, and both these two half cell reactions should be balanced in mass and charge. We see mass, two hydrogen on the left for the anodic reaction, two hydrogen on the right for this anodic reaction, one oxygen on the left, one oxygen on the right. This one is not count because it's a side and it's vacancy, so there's no atom here. Okay, so two hydrogen, one oxygen on the left, two hydrogen, one oxygen on the left. Zero net charge, this cross means neutral, means no charge. So zero net charge on the left, two positive for oxygen vacancy, two electron, two negative. So net is zero charge on the right. Okay, this is, we have assured the mass and charge balance for the anodic or the oxidation half cell reaction. Then for the other side, we have two oxygen on the left, two oxygen on the right. Okay, again, this oxygen side don't count because this is vacancy. This one, the oxygen is occupying oxygen side. So net we have two oxygen on the left, two oxygen on the right. How many charge on the left? So 2 plus 4 plus 4 minus 0 charge on the left. This cross, remember we said, means neutral. So 0 charge on the right. So the cathodic or the reduction half cell reaction is also balanced in both mass and charge. Okay, so then this is a single solid oxide fuel cell. Electrolyte in the middle that conducts ion, in this case oxygen vacancy, and then on the anode the fuel got oxidized to release electron coming out, and then on the other side, on the cathode, the oxygen gas got reduced to form lattice oxygen. Okay, and this is the basic component: anode, cathode, electrolyte for a single solid oxide fuel cell. And of course, as electron goes from the anode through the external circuit into the cathode, it can drive the external circuit elements such as a light bulb, and the conversion from chemical energy stored in fuel versus oxidant such as oxygen to electricity. The conversion from chemical energy in fuel and oxidant to electricity, this conversion is achieved. That's why we call fuel cell is a type of energy conversion device. Okay, and quite often we don't really talk about secondary fuel cell, but in principle the fuel cell can be used in reverse fashion. You spin the electricity to create chemical fuel or electrochemical fuel synthesis. These are some newer development. People sometimes call those devices reversible fuel cell. But here, let's focus on fuel cell, which converts chemical energy in fuel to electricity through electrochemical reaction. And this chemical energy, unlike in battery, is stored in either gaseous fuel, like hydrogen gas, or liquid fuel. You think of methanol, or sometimes even gasoline or diesel. Okay? And then we have anodic or oxidation half cell reaction. We have cathodic or reduction half cell reaction, and then we can combine these two with the same goal to eliminate what? Eliminate electron, and then you can manipulate to get the overall or full cell reaction, which essentially will be two hydrogen gas on the anode side plus two oxygen one oxygen molecule, O2 molecule, to form two water molecule, and that would be our overall a full cell reaction. Okay, so this is a brief fuel cell introduction. It's like battery, convert chemical energy in gas or liquid fuel into electricity. The oxidant is most cases oxygen gas. Three-part electrolyte that separate the anode and the cathode. Anode oxidation half cell reaction happens. Cathode the reduction half cell reaction happens. This is the same for all fuel cell, except for different fuel cell may have different electrolyte material. Different fuel cell may have different anode material, or even cathode material. Okay. And then you provide fuel in one side. On the other side, you may have so-called exhaust fuel, which means the fuel with less hydrogen concentration but more water concentration. For this case, you have oxidant coming in like air into the cathode side. On the other side, you may have so-called depleted oxidant, depleted air with lower concentration of oxygen gas in the other side. Okay.